Hello, I figured I'd check in with you all again. Today I'm going to talk about why I'm here in the Netherlands, like exactly what I'm doing, what my mathematical research so far has revolved. So first off, I'll explain. So I'm a PhD student, and so part of that entails me being in a classroom, at least like more of like a homework work session where students come in with their homework problems and they're working through them, and then I help them with some of their questions. And so that's fairly standard at a lot of universities. One of the challenging parts has been the class that I'm tutoring or that I'm assisting with. It's in Dutch, and so I don't speak Dutch, so that's been a bit of a challenge. But thankfully, they have at least a fairly similar version to it on, or like the class notes online and the class problems online, and so I have those PDF files that I ran through Google Translate, and so got at least an idea of how it's supposed to go. But we have somewhere between 20 and 30 students kind of show up to these 2-hour homework sessions twice a week. And like the student, I mean, so when I go and talk to them, like they ask their questions in English to me, and obviously I respond in English. There's only been like a couple times where it's been kind of an issue where uh, like they're new to some of the mathematical ideas, so when they're trying to express the mathematical idea, that's tough, especially when it's not in the language that the text is in, or and it's their second language. That is a bit of a barrier, and like I go through their homework problems beforehand, and like so I know what the homework problems are, but I have to remember exactly, is it for every x there exists a y, or is there and there's a lot of the math translates as far as like, oh, it's like the math equation. I can see that it's a definition of continuity, or the words are similar enough that I'm like, okay, so picking up that if how they spell point is really similar to how we spell point. Yeah, but that's been going well, except when Google Translate messes up. So I thought they had an assignment due the day, or it was being returned the day it was actually due, and so I told them I if sorry I had them I announced that, hey, you need to turn in the assignment. I'll get it back to you next week, and so got lots of big eyes as far as like what. But thankfully, the other TA is actually Dutch, and so he was able to know it's we'll collect it next week and then we'll return it. So um, yeah, we have that, and then grading parts of that. And so that's like part of what I do, but that's not like the main focus of why I'm here. So to talk a bit about that, so my undergrad, I worked with Amitesh Sarkar, or Dr. Amitesh Sarkar, on percolation. So like understanding how basically you can think of a fluid flowing through a sponge, and the question is, okay, like if the sponge has enough holes in it, the water should pass through no problem. But if it doesn't have a lot of holes, then it'll be really hard for the water to pass through. And so you can think about modeling the sponge as through this kind of like a random grid, like imagining there's a grid full of like a grid paper, and then you're just adding in edges uh, randomly, and seeing if there's a path from the top to the bottom, which would be like the path of which water could flow through. So that's what I did for in my undergrad, and then for my master's project, I studied information theory, specifically Shannon's theorem. And the idea is like when you send messages, um, the like very simple messages, sometimes they can be distorted by just, or not, they can be, but they will be distorted when they travel across some medium. And so the idea is, if we understand a bit how often these errors occur, is there a way that we can correct those errors, and what can we do like beforehand in order to make sure that we're not going to have a lot of errors. And so one way you can do that is, let's say if I wanted to say the message calculator, then I could say the message calculator to you 3 times, and if things didn't get too crazy, I mean, if I just said calculator once, then maybe it would come out slightly different than that. But if I said it 3 times, well, okay, maybe one of them got messed up, or maybe even 2 of them messed up, but between all 3 of them, you should be able to parse together what I said. I mean, that's why you ask people to repeat themselves when you didn't understand the first time. But there's better ways to like encode messages than just repeating it yourself 3 times. Like that's a very slow way, and you have a chance. Like it's not the best way, and so there's better ways out there, and so that was part of that project. And so now I'm moving back towards like the percolation side of things, but there's flavors of both that are really connected. So kind of the idea of breaking everything down to ones and zeros as far as like events, things happening or things not happening. Of course, randomness is like always the underlying idea. But recently, like what I've been looking at within that kind of framework is influence. So some events are more influential of determining an outcome. Like example is in the U.S. Election that we'll have in November. There are some states that are more influential on the outcome than the other states. So as far as which state, if you flipped it, would the election go the other way? And so Florida is like a classic example. I think Nate Siller was saying it has like a somewhere, I think a 15% probability of flipping the election, which historically is, I think, low. But yeah, so I'm studying the idea of influence as, with regards to these what we call hypercues, but is basically just a string of ones and zeros. And so that's kind of what I've been focusing on lately. And the cool thing is it's bringing in a whole nother branch of mathematics called Fourier analysis, which essentially is instead of taking the function as is, we're looking at a transformation of it that gives us certain information that we originally don't have. And it seems kind of strange that we have this very binary system that we're doing Fourier analysis on, because Fourier analysis is very thought of as like it's a very continuous kind of idea. Like when you're dealing with like lots of like the real numbers, or not more complicated functions, but functions from like R to R. That's the kind of functions that you'd be expected to deal with, not functions from 0, 1 to 0, 1. So that's been kind of cool, and there's been like, it's cool because there's like flavors of the ideas behind information theory showing up there. So it's been nice seeing some ideas come together from that. So that's kind of where I'm at. I still like don't know as far as exactly what direction I'll be going for my PhD research, but this is like a really big underlying idea, and an idea in discrete mathematics that is super helpful. So I think that's all I have to say. Fun facts, today I ordered Domino's pizza. First time like ever ordering pizza like delivery, and they have that in the Netherlands, so did that, and then yeah, I think that's it for now. I'll talk to you guys soon.